So when retrofitting our walls, we typically do a blown-in drill and fill type insulation, or gut them and do a bat or spray foam. Sometimes we're lucky and want to ensure advanced durability, so we put exterior rigid insulation on the outside. Often this is a very carbon intense type of foam product. But there are some more natural ways we can insulate that use less embodied carbon, healthier materials, and that can be locally or regionally made without the risk of water or durability failures. But how can we do this? Join us today for a discussion on retrofitting with straw bale and a slight discussion on blown-in hemp insulation. Support for the GreenHome Institute comes from Timber HP. We are excited to announce that now through December 1st, a large discount is available for first buyers of their new timber board exterior wood rigid insulation. This is 100% made in the United States, wood-based insulation that is decarbonized. Go to timberhp.com/pre-certified timber board to learn more and access the product in discount by December 1st. Additionally, consider Timber HP's offerings for full blown-in wood fiber and interior bats. All right, well, I want to welcome everybody to Exploring Humidity-Resilient Straw Bale Retrofit. This session is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. This course, like many others, is approved for multiple continuing education units, including 4 pillars in our certified GreenHome professional designation: energy, health, materials, and place. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check out that 5-digit Passive House code sent to you at the end, as long as you're here for the entire CEU approved hour. So with that, I am really excited to hand it over to our speaker here, Andre with Western Michigan University. Andre, welcome, and please take it away.
Thank you very much. My name is Andre, and I am a research and development engineer at Bronco Construction Research Institute at Western Michigan University in Kalamazoo, Michigan. Our bulk of our research is focused on structural retrofitting and structural resilience. This shows our lab on the left side. We are located on the airport. It's an old school of aviation in Kalamazoo, Michigan. We have a couple of interesting pieces of equipment in our laboratory. We do dynamic wind uplift simulations on low slope roofing. We can do sizes up to 12 by 24 feet assemblies. And we also have a load frame testing setup where we can test full shear walls. And so we do a lot of internal funded research, mostly on structural resilience. And this is applicable in wind and seismic zones. And so that's our bulk of what we do here at the Construction Research Institute. But lately, we've been working with the Department of Energy, trying to understand how we can optimize retrofitting methods, because this is something that we're battling here in Michigan. It's the cold, and then we're using a lot of energy to heat the homes. And so we are looking closely at the retrofitting techniques. Just a caveat: this is kind of one of my pet projects. Almost, working with natural materials and trying to bring them into mainstream. And as we advocate more for these technologies, we ask ourselves, how would it perform long term? And these are the type of questions that people around us are asking. It's like, oh, we heard of straw bale being used out in Southwest where it's dry climates, low humidity. But how would it work in Michigan, for example? Here I show a picture of a shear wall being tested. We are adding, just as a side note, we are adding structural adhesives between the sheeting and the framing, and we are getting tremendous capacities for shear resistance with these systems. And this would be your alternative to mechanical fasteners, like fortified programs or something like this. We can get the same type of performance out of these walls by using adhesives, but a lot lower cost point. But anyway, we took one of these walls, we took off the sheeting and said, well, we're going to demonstrate how to retrofit a stick frame wall with straw bales. I have done this several times, as far as 5-10 years ago. And so we want to kind of show the entry into this type of retrofit with straw bales. This would be for your do-it-yourself crowd if they're do-it-yourself capable. And we presented this at the Skillshare gathering at Tillers International this summer. And as you can see here, we had this. So sometimes we do demonstrations for groups of people. We had about 30 people in attendance here. We see a gentleman here cutting into the straw bale. It's the straw bale cuts really easily with the chainsaw. You can notch it around the stick frame wall, so it will be flush with the exterior surface. And we showed people how to attach flashing in the J channel that would receive your stucco product, and trying to isolate the stucco from the wood members for thermal expansion. And the students were analyzing the outcome and trying to understand what it would take to retrofit. So with this method, you're obviously losing a lot of space inside, and it's kind of invasive. This would not be practical for a lot of applications, but it would be something that people can get into without having to extend, for example, the roof line to have adequate overhangs for this technology to work. But we want to understand if there is a way to do it from the outside, from the exterior. And if you look at current funding streams for these type of projects, the government's looking at this. When you look at the retrofit strategy column, you'll see that the exterior rigid insulation over existing siding is being studied. There's a lot more studies than this, but they get into the exterior retrofitting over existing exterior siding. So I think University of Tennessee is doing this, and these are some of the study and reports that you can look at. And what does that look like? So what they do is they would, like the Fraunhofer product, you just without disrupting occupancy. That's what they like, is that you're not disrupting the occupancy, and then you're increasing the thermal resistance of the building envelope. And there's all sorts of other methods to do this. On the bottom, I say LiDAR and point cloud generation. So there's other manufacturers that do large panels, and they would scan the outside of your building and generate a point cloud, and then CNC cut inside a factory a panel that would be able to be installed over the outside. And this is notwithstanding the hygrothermal properties. I mean, how does this affect the hygrothermal vapor drive? Something that is missing from these studies. But at this point, I'm questioning myself, can this be done with straw bales, for example, because always looking at the natural alternatives. And it turns out that there's some anecdotal evidence out there, especially in the Southwest. If you see this Paca construction, there's some snippets. So what they've done is they added the straw bales on the outside, and you see that you kind of create these the window wells, which is like a featured hallmark of the straw bale construction on this left picture. So there's a blog that this gentleman created, and looks pretty interesting, and that's his project, so you can follow it. So this type of method is nothing new. People are already doing it to do a straw bale wrap. And if you look at the other side of the pond in England, they have a whole training. This is I was perusing their website. I mean, you get the British gentleman with the big hammer here, trying to hammer these bales into shape. his method is a little different. I mean, he doesn't put the buck on the outside to offset the window, put it on the exterior surface, but maybe he'll do that in the future. But this detail kind of shows what those straps are all about. Those straps are anchored into the existing structure for those bales to be, in plane and not having any out of plane um, movement. So these methods do exist, and I know. Well, I was introduced to a living energy farm in Virginia, and they have done this a quarter century ago, 25 years ago. They've been applying these methods to do an exterior wrap, and since it existed, so our thought would be to analyze it for moisture content. How has this system performed over 25 years, this straw bale wrap? Because it's um, you know nice that you're not disrupting the occupancy during installation. It's natural product, but what's its long-term durability? And how do you actually go about doing it? What is the architectural detail that's necessary to carry this through? So first, I'll talk about the applicability. I'm looking at Kalamazoo, Michigan, and I'm looking at Louisa, Virginia. This is where we went down to probe these houses. There's two examples of them, and so I'll go through some climatic analysis here, see if it's applicable. These are the average monthly temperatures for both Louisa and Kalamazoo. And then you can see that in Virginia, it does freeze in December, January, February. So they go through freeze thaw cycle. So that's checked off. The average monthly precipitation actually rains a lot more in Louisa than in Kalamazoo. So that checks another box. So they already have a worst case scenario there. We have more snowfall, but they do have snowfall there. This is average monthly relative humidity. It's even more humid in Virginia than in Kalamazoo. Well, we beat them in November a little bit, but I mean, the profile kind of is the same. And then the average monthly dew point, it's even higher in Louisa, but what does that mean? Here we have temperature versus dew point. I mean, the profile again is the same. And with this dew point, what's interesting is the estimated dew event frequency by month. Because you might have a dew point, but you might not reach it. You might not actually have the dew present. So they have dew present in Louisa even more so than Kalamazoo. So we're the same or better humidity wise. So that kind of checks out that. When you go look into the code, because Michigan adopted the straw bale appendix, it's an IRC, and it tells you that when you're installing these bales, that they ought to be 20% or less in moisture content by weight. So I kind of summarize here in this table the likelihood of biological activity versus the moisture content. So they say, I mean, obviously these are minimal standards. So yeah, less than 20%. But in my table, I already said it's high. The active mold growth, bacteria activity, decay likely. So they're, less than 10% you're dormant, 10, 14 minimal biological activity. You definitely don't want to be above 20%. That's the bottom line. That's what's in the code. If you read the code thoroughly, it says 20%. So
So,
how
do you so for the code, that's interesting, and I wonder, are code officials actually savvy enough to be checking these kinds of things in the field? Is that something they're going to check? Is that going to be part of the application when you pull a permit and they see straw bale? Are they going to actually come out and verify it, or is this more just like, here's some general good ideas that we hope you follow?
Well, so I built a straw bale house. It was the first straw bale house in Kalamazoo County. I have an occupancy permit for it now for about a year.
Mhm.
And the permitting process was astonishingly simple. I mean, that you just have to kind of educate whoever's doing it. And
Right.
uh, basically they will not have an idea about this. This was never checked, but
Right.
I did my due diligence. I'm not gonna put
Right.
bales into my wall. But for example, the my structure was timber framed, and that requires somebody actually coming out and grading your lumber, and
Oh,
they will do moisture content. So this is not as sophisticated on the straw bale side as far as the code goes. I mean, this is the way you would go about it. You have a bale needle. This is basically what it looks like. This is a an instrument that you can get in Tractor Supply type place. Is it a? I'm showing. This is what we got for our lab. It's Agratronics, and it's a 20-inch probe that will probe the 18-inch two-string bale completely. And so basically, this is what I call the moisture content percentage formula, and you can calibrate this against the ASTM standard test. We have done that in the lab, and this piece of equipment is for it's scientific grade basically. When you do oven drying method, and then you correlate between the two, so it was a pretty good piece of equipment. So the so that's basically the however you're going to be measuring this. The Again, I go into a little bit of on the mortar side, on the mortar mixes for the stucco. Obviously, as the lime increases, content increases, then the compressive strength decreases. Um, this is just I put this in there because when I asked Alexis, the gentleman who owns these houses in Virginia, he said that this is what he did. You have this is what he used, the commercial type, and so it was a concrete stucco. It was not, and I was kind of surprised because in this community, that's kind of frowned upon. You do lime stucco, or you do some sort of an earth blaster. But what he has done with a Living Energy Farm, Alexis, what he did was he used commercial type N for the first outdoor coat. And then, well, I'm sorry. So those are the coats that he used. And then the last one was the durable exterior coat with added important cement for weather resistance. So those were his stucco mixes, and this is the detail comes from his book here. So what it was a pre-existing block wall, and then he put these posts, and then there was a support bench and wooden shelf here. And I show how I was using the probe. So I probed below the surface. Then I went halfway in. I did a measurement midway, and then I probed it all the way in, and I did the block interface where the straw bale touches the block wall. So those were my 3 points. So this is what that shelf looks like from underneath. So I kind of crawled underneath there. And when we got there, this is where the foam is. That's the existing block wall. And then this post is what Alexis installed to create this support for the straw bales with the support beam and the wooden shelf. This is what it kind of looks like from a side. So the straw bale is elevated from the ground because it does snow there. So this is how I was basically measuring here. So I stuck that probe 2 inches, and that's my location. That's 8 inches above grade to kind of give you an understanding what I'm doing here. Um, then this bottom picture here on the left is I'm 48 inches above grade, and I'm sticking that probe in 10 inch deep. And here on the right side, it's 12 inches above grade, and I'm sticking it all the way into the block interface. It's actually a typo. It's minus 20 inches. Okay, so what are the findings? The moisture content by depth by location. So we did two houses. We did Wood Folk House and we did Magnolia House. Those were the two houses in Virginia, in Charlottesville and in Louisa. And so what each one of these lines is a location, and then so for example here on this left graph, the location is that location had 8% moisture content. This is 25 years into it. So, numbers look pretty good. It's everything is below 20%. You have anywhere right below the surface, you have anywhere from 8 to 15 on this woodfolk house, and anywhere from 8 to 19 moisture content right below the surface. So I break it down then. Average percent moisture content versus elevation above grade. So obviously, as you go up above the grade, your moisture content is going to be lower. So that's why they say, start your bales at least 8 inches above grade. Here's percent moisture content versus elevation above grade, and this is just on the north face. So as you're going higher above the grade, the moisture content is going to be lower, but still within reason. So more graphs. It's the relationship between the average percent moisture content versus depth in bale again. So this is not looking at above the grade. This is looking at in depth. So as you're going into the bale, the moisture got lower. So it was except over here was reverse, but that's what it is. Still within acceptable limits by code, and actually well below. So that kind of concludes the discussion on the straw bale retrofit and straw bale wrap and the moisture content in these systems. So okay, go ahead.
Andre, before you
Question.
get into that, yeah. So thinking about pests, there was a specific question here about concerns from mice. But just in general, any other kind of pests, termites, whatever it may be. What are some of the challenges, opportunities, or things to think about with pest management?
Oh, pest management. This question gets asked quite a bit. I mean, the pests are no higher and lower in probability than a wood house, I would think. During the inspection, I didn't see any pest damage. The standard practice is to use a borax and boric acid for when you have a ground contact or the first couple of courses, you do want to put some sort of for lack of a better word, rat poison. That's the boric acid or roach killer. That's what the boric acid and borax are. And by the way, they're natural minerals, I believe. So,
Right.
but mice and anything else, I think that the mice will get into just about anything. I guess having cats around, I don't know. But I haven't seen any damage from pests, and I know that they used pesticides during application. You kind of dust the bales. So before you put the first course of the bales down, you definitely want to dust your substrate, and then you put your bales, and then maybe subsequent course would have that pest control, the pesticide in it. And then it's also fire retardant, but I mean, you don't necessarily need it if you're encapsulating it with the stucco. Hopefully that kind of answers your question.
Yeah. And then these moisture readings here, just remind me again, these were taken by the just the one snapshot in time, or was there any kind of sensors that you looked at over time?
No, this was in middle of summer. This was the last week of July, first week of August of this year, and this is 30 years into or 25 years into this retrofitting. So
Oh, okay.
the wood folk house was retrofitted in 2000.
Hmm.
So this is kind of like a long-term durability. I'm to clarify. So
Yeah, yeah. Um,
basically, this was the whole point: a long-term durability study in a humid environment.
right, right, right. And was there any other like considerations about the, ability for moisture to move through the siding or the interior walls or dehumidification being present within the homes at all? Like, actual full-time dehumidification?
Uh, the no, I mean, so when you're talking about natural building, I mean, you want to have some passive systems that do this. So they had
Yeah,
passive system, and it wasn't musty or moldy inside the house when I inspected it.
yeah.
Um, uh, basically, can you repeat that question one more time?
Well, I think maybe the question, yeah, just was, whether also the interior humidity was evaluated if they had,
Okay, yeah, yeah. Moisture
yeah,
intrusion. Yeah, why use the cement stucco? Because we know that permeability and the breathability are an issue. That's why, natural plasters are much better when you have a system that's. We are talking about retrofitting technique.
yeah,
So this was a block wall that is by nature impermeable, and then so the to advocate for this type of technique would be to. I mean, you're going to have a vapor barrier. I
yeah,
assume you're going to have a vapor barrier, so there's not going to be any vapor drive or vapor intrusion into the system. And since these bales were laid against the block wall, that it's already there's no moisture coming out of the house into the bale system, so you don't necessarily want to have moisture coming into the bale. So the thought was to use the concrete stucco, the concrete mortar, and which I specified in that table. And right, wrong, or indifferent, this is what it is. These are the findings after we probed them. So the consideration wasn't paid into moisture drive or permeability through it. Like you want to have a breathable wall. Here, you actually don't want that to breathe. I guess
right.
would be the bottom line.
Interesting. That's very, uh, yeah, that's very interesting. So one of the questions, and I think you're speaking to it right now, right? We're seeing it visually. The answer before our eyes was, what is the shelf life, right? Or what is the how long is the life expectancy? And of course, I think that's like asking the question of, hey, you just built your house. How long do you expect it to last, right? 100 years, 200, 1,000 years. I suppose we're answering that same question. We have to fairly answer that same question for every house, right?
Correct. But again, to reiterate, this is a retrofitting technique. This is not a new construction. So, basically, we're presenting this as a retrofitting technique.
Right. And I guess I meant to more say like, when you retrofit your wall or add new siding or insulate it, in theory, you're boosting its life, right?
Yeah.
Yeah. Rather than, and so I'd imagine if someone was to do an exterior rigid insulation with foam versus this, the lifetime of that, I mean, any thought on what those lifetime comparisons are?
Well, I mean, we're wrapping up a study, and then we are looking at houses in retrofitting housing stock here in Kalamazoo, and then we go in there and then say, well, I look in the attic. I do 30 inspections, and I look at the attic, and you have R19, R25 in the attic because the house is 50 years old, or maybe 25 years old house and has R39 or something like this, not up to code, but it's blown in fiberglass insulation, so it's synthetic material, right? But it's full of mice nests, so
Right.
you're gonna have this problem. Even with synthetic insulation, it's gonna degrade. The blowing agents are gonna escape, so you're gonna derate your R values. So comparing to conventional, I don't think this is too bad of alternative.
Right. Yeah. Yeah. And then one final question here on the straw was something, can you speak to silica content of straw bales? Or
Silica content of straw bales would be more of a function of geographical location. I mean, depending on what the straw you're talking about, this product would come from different type of plant matter. You know, wheat straw, rice straw,
yeah.
different cereal grain straw. So it just depends. This would be a function of geographical location where the product comes from. Um, to that point, when we're doing a project with Strawbale, we have a source that produces very constant product. The bales are tight, they're mold free. The equipment that produces it is newer, so the consistency is much better, and the tightness is much more the compact, and the practice is how they bale it into super bales, so 21 bales get packed in, so it's easy to do material handling. So the silica content question would be it depends on the variety that it comes from, and also geographical location obviously would be. So that's, I hope that kind of answered the question.
Yeah, yeah. Okay, well, thank you.
Okay, maybe we can move on from the straw bale into the hemp.
Yeah.
Okay, so we also did a trial this summer with hemp blown-in insulation, because there's a need to kind of look at the alternatives, natural alternatives to blown-in insulation. And so we conducted a trial, see what the barriers would be to install hemp product blown in grade through an existing equipment. And we have done this with one of the largest retrofitters in Southwest Michigan, Better World Builders. And what you can see, this schematic here on the top left would be the setup that we used. We had a 4-inch ID hose with a 1 5/8 end effector. And this particular house is a training center, and the inside detail is replaced with plexiglass. So in lieu of having a drywall or some sort of a gypsum board, you would have a plexiglass. So you would see how that cavity is being filled. And so that's an ABC here on the bottom. You see how we were filling in the cavity. So the hemp product, the speed of installation was very comparable to chopped up newspaper or different type of product. So the cycle time was about four minutes per cavity. So there was, very comparable to recycled newspaper. The virgin hemp product was. And let me advance the slide here. So basically, what we are looking for, what kind of R will we get using this, and so we were getting, those are the two black dots are the two data points. We did two cavities, and then we disassembled the cavity and measured the weight of the product, and then kind of established density and R value from there. So it packed nicely. Basically, that's what it boils down to. And we were able to get machine parameters for this hemp to be blown in. Crandall 2300 we used for that, and so we tuned the parameters, and then it worked well. It was less dusty than chopped up newspaper. So then we did use case, see how much carbon we would save a year if because the product was similar in cost. You're talking about $11-12 per bag versus $13-14 per bag or something like this. So the price was comparable. So in our opinion, there's really no barrier into entry into the market with the hemp, specifically on the blown in side. With this product, you can enter the market without any barriers. And this would the carbon accounting for this use case would be as such. So, I mean, in America, I don't know, in US, the carbon market is not well developed. So, and the market value, the voluntary market value from switching from at 12,000 bags a year, at 25 pounds, you get 300,000 pounds of material, and you would go from 50 grams of CO2 emissions per kilogram of that material. So you would actually save 40 tons of carbon by switching. On the carbon credit scale, I mean, you're talking about $1,000, maybe a little bit more in Canada. Canada would be probably $3,000 you could save. I mean, that's somewhat of an incentive from switching. If you're getting the same R value, it works the same. You don't have to do anything to your machine setup. And then if there was more of an incentive on the carbon credit side, so I kind of computed that here. Then I want to look at, for last couple of minutes, I modeled the straw bale wrap. I modeled it in Energy Plus, and I did it on this scenario. This was an actual house, and I modeled in Energy Plus in Open Studio. And I got the energy bills from that house. These are energy and gas bills, and I have basic parameters for this house, for this use case, the volume of the house and whatnot. We did door blower test too. To use the door blower test is at it's at 50 pascals of, and then but you want to convert that to natural the natural ACH into the modeling program. The Energy Plus doesn't take the door blower test at 50 pascals. You kind of have to convert it, but that can all be done. So I did a couple of scenarios. Oh, okay, actually, this is how I built the model. This was a HUD home in Battle Creek, Michigan. Those are the sub-assemblies and then the ASHRAE templates, Open Studio templates that I used for the interior walls and doors. I wanted to look at just insulating the basement. This was uninsulated. I wanted to see what would happen. These upgrades, upgrade 1, 2, 3, 4, 5. Upgrade 4 is straw bale wrap and lime plaster. And I cost it out like this. That's what, I mean, people are not doing it. This is what it would cost me to do it per square foot. So that would include that a bale installation, maybe doing the post and shelf, like I showed you that detail all the way around the house. So it's not cheap, especially, people are not doing it. So you're not going to find people wrapping houses with bales. So that's just an estimate in labor and material per square foot. So this is modeled, the baseline, and with the straw bale wrap, you would save, without doing anything to the attic, you would save 11% on energy a year. And then so yeah, okay, moving forward. It looks much better on the carbon accounting. You have the carbon payback would be even negative, I guess, in this case. Oh, this is interesting. So the simple payback, I'm just looking at how much energy you would save in dollars. And then see what the ROI would be in years. It's interesting. I've done this with Snug Pro. The Snug Pro overestimates. If you were to run this in Snug Pro modeling software, it would overestimate the basement insulation. The Snug Pro would pick number 2, and it would probably give it 7 years simple payback. But that model is tuned into energy bill, and we know that when you're doing house modeling or the energy modeling, it's over parameterized problem. There's so many parameters. You can tune the whole model to reflect the energy usage by just infiltration numbers. But I mean, we know that there's a lot more parameters than that. The the ROI of the Strawbale wrap would be 359 years. So anyway, and that takes me to questions and answers.
Yeah, great. So I think the other question that came in here was one about fire ratings, just speaking to the fire ratings both for straw bale and hemp, and whether there's a difference in that rating, whether it's new or I guess existing, if that changes anything.
Okay, yeah. So with the blown in hemp insulation, that was fire rated. And what they do again on that front is they mix the product with boric acid again, the same as the pesticide, I would think. And then they load the cellulose blow-in insulation with the same fire retardant agent. So same. On the straw bale side, the straw bale doesn't really burn that well to begin with. It's kind of like a phone book. It will char on the outside, specifically when it's encapsulated in something like lime plaster. It's very good fire rating, and then if you upgrade that to the cementitious mortars like a Type N mortar stucco, it gets even better. Anecdotal evidence from the California fires points to the fact that these houses do survive fires, wildfires. So I hope that answers the question. You're muted.
There we go. The next question is, did you use the existing structural wall or add a second 2x4 wall inboard in regards to the home you're referring to for the hemp blown in?
No, that was just that's just blown into a standard cavity. Um, that's a lot of the houses are not insulated. Here we have the balloon frame housing, and the cavities are uninsulated. So what they do, they would drill a hole on in the siding or the exterior cladding, and then they stick a hose up, into the cavity and fill it. And that's why they have that training house, because you really need to be a skilled operator, because you don't have any. I mean, they used cameras. They have like they can snake a camera in there, but you need to be a very well trained operator to understand what it feels like to fill it completely. And that's why they have a plexiglass from the inside, so that it's a training house, and to train these operators to completely fill the cavity, because you will feel it. You will feel the feedback from the system as you're blowing it in. It will give you feedback. So a good operator will fill a cavity 100% of the time. So no, there's no. It's not additional. No additional framing. That was just retrofitting a old wall that doesn't have any insulation. In some cases, if there's insulation and if it has failed, let's say it had a fiberglass insulation that has failed and then it's settled over time, there's a way to go in there with a vacuum and vacuum it out, evacuate the whole cavity and then fill it back up with virgin material.
Yeah. Great. Well, we got some more time for some more questions here. Before we get to them, real quick, everybody, as a reminder that this session is being recorded, and we will post it up on our YouTube channel in the next couple days. So you can check back there then, or you can head there now, click subscribe, hit the bell, and then you'll get an instant update when the session is available. For those of you watching this in the future, not right now, but on demand, take your quiz with an 80% passing rate to receive your continuing ed. For those of you here today looking to get your continuing ed, as long as you've been here for the entire CEU approved hour, take that survey that pops up at the end, and then check your spam in the next day for certs@gutenbergcerts.com, and you'll receive your certificate and CEU information there. And again, before we jump into any more questions, just a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly 500 members. We're trying to reach 500 by the end of the year for our 25-year anniversary, so help us get there. And all of our sponsors, such as Rheem, Panasonic, Timber HP, Build Equinox, Tamrac, that help with products that can help you achieve more sustainable outcomes within your projects that you're working on. So, yeah, so I guess another question that came up here was, I mean, you were speaking to some of the different costs, with obviously being a challenge because, folks just simply aren't doing this kind of thing. So is it really just more of a matter of needing, someone more available in the market to drive some of these costs down? And if some of this stuff is being supplied locally, would it, some of the material costs themselves probably end up being cheaper than some of the other alternatives?
Um, I would have to go back to Alexis Ziegler from Living Energy Farm, and he would reiterate over and over is that community is the technology that makes this whole thing work.
Right.
It's labor intensive, and it we're talking about house affordability,
Mhm.
and when we talk about, I mean, talk to contractors, and why is it all so expensive? Because people are not DIY capable. So
Right.
the house construction is expensive because everything is done by a professional, and then they want to have a living wage, and that's what it costs.
Sure.
And if people, I mean, some of these technologies and then intake of this technology is predicated on the DIY capability of people who are interested in it, and also community. Like when we build these Strawbale projects, there's community involved in it. I mean, it's a low skill type of labor, stuccoing especially, or throwing bales. I mean, kids can do it, but you have to have a foreman who knows what's going on the site. That's what I would encourage people. If you have, I know a couple of natural builders who are doing it in the area here in Southwest Michigan, and they could supervise crews of people. I mean, if you have somebody who's good at applying stuccos, he can really, or he or she can really teach a crew of unskilled laborers, even someone who's volunteering for a day. So that's how you
Sure.
cut costs. It's the community is the technology that makes everything work.
Yeah. And do you see on that note a lot of maybe Habitat for Humanity type agencies who are volunteer powered? That's their whole, or well, it used to be. I know in some ways that is changing with some, but in most cases they're still relying on a lot of voluntary power. Do you see this happening more so with those types of affordable housing projects?
Um, yeah, it's interesting that you mentioned Habitat for Humanity, and we were doing projects down in the hurricane coastal areas, and they
Mhm.
stopped using volunteers specifically during the COVID, because I mean there was
Yeah.
not, so they stopped doing that, and then they're they're becoming developers, so they're
Yeah.
cranking out dozens and dozens of houses. I would want to think that it I there should be an alternative into talking about habitat. I would go even lower than, I mean, than that. I would think that manufactured homes, your trailer parks, I think that they could benefit from that, and um, retrofitting those with straw bales might be interesting, something to look at.
Sure.
Um, Yeah, I mean, it's a natural type of material, and people like working with it. That's my just anecdotal evidence that every time I introduce this to a group of people, they like, and they like the smell of it. I mean, it's a little dusty, but it's fun to work with, especially when you get into working with mud plasters and things of this nature. So it's
Mhm.
it's not that. not that toxic, and then the final product doesn't have many VOCs, and so there's these benefits. But um, as far as this technology being uptaken by these organizations that work with volunteers, that would be a question for them, I guess.
Yeah.
I would so welcome it, but we're just doing research. We're just giving people data and then
Yeah.
empowering people with confidence, basically.
Yeah. Yeah, sure, sure. Fair enough. So question here. Let's talk about a drying direction for the wall assemblies of straw. Is there a standard rule of thumb for location of the water resistant barrier, WRB, and vapor barriers? And then kind of in brackets there, they said, I understand that bales should dry outward through a cementitious plaster type finish, but can it work drying inward or etc.?
So I guess uh, to unpack that question, are you specifically talking about retrofit, or are you talking about new construction? In
Well, let's,
retrofit,
yeah, go ahead and answer both if you could. I mean,
okay,
yeah.
so in retrofit, I don't think that there's going to be much vapor drive. Basically, the original house envelope is going to be completely sealed against moisture, and it's going to be moisture impermeable and vapor impermeable. Just so I guess that would be then you would have to have some mechanical systems inside to exhaust excess humidity.
Mhm.
Since it was a block wall, it will not store much moisture. So if you in this retrofit scenario, I mean we can go into a hydrothermal modeling, but I have a hunch that you don't want the assembly you don't want moisture to enter the assembly or you don't want to have that vapor drive. And that's what the case was in Woodfolk House and Magnolia House in Virginia, and the numbers speak for themselves that the bales are completely dry after 25 years. On the new construction, when you're doing new construction, you definitely don't want to have vapor barriers of any kind. You want the wall to be naturally breathable, and so that's why you're using stucco and natural plasters, and you try to balance them. If you do end up using different type of lime, let's say lime plaster on the outside and then clay plaster on the inside, you want to balance the thickness so the vapor drive and permeability is about the same. So you want to have a thicker on the inside of clay plaster and thinner lime plaster, because they're going to have a different permeability. If you're using the same material on the inside and outside, you want to have the same thickness. But bale walls in new construction, you want to have a vapor drive, because the second law of thermodynamics, you're going to have a vapor drive uh, um, throughout the year. So you don't want to have any moisture barriers.
Yeah. Great, thank you. And I wanted to just point out, somebody shared here that in Benzie County, um, Michigan here, they created a brand new program for inspecting. As they mentioned, the inspector had never encountered anything like that. They brought a bale moisture reader and tested 20 plus bales, and the county accepted this result. Otherwise, it was a normal inspection. So just something interesting to share that there's um, the inspection knowledge is building, I guess. So
Well, that's good. Like again, you don't want to be beating the inspection. You want to have a good dry bales for your own house. I guess if you're doing it for somebody else, you definitely don't want to be installing wet bales. So not only to beat the inspection, but for your own personal satisfaction and craftsmanship, you want to use the good material.
yeah. All right. Well, with that, we're at the end, and I don't see any other questions. So, uh, Andre, maybe you can remind people where they can go to reach out to you, learn more, or follow what you're doing.
Yes, we are. This is our BCRC Bronco Construction Research Institute website, and we post our newest research findings and peer-reviewed journal papers on there. And Here's my email and phone number. You can give me a call or write me an email with questions and concerns, and maybe some collaboration. That's great to hear that the Strawbale movement is alive and well in northern Michigan and in Traverse City area. That's fantastic, and let's be cautious moving forward in wet and humid climates, and let's do due diligence, and because we do want to build for 100 years, we don't want these things to or retrofitting techniques or new construction, we don't want them to fail.
Mhm.
And I hopefully this will move the needle a little bit forward and give people a little bit more confidence as we promote these technologies. So thank you very much for your time.
Yeah, yeah. Thank you. Thank you so much to Western for having you out. And take care, everyone. We're off next week, but we'll catch you the week after that. So goodbye. Thank you.
Thank you.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.